Hello guys, today I am discuss about the surface development and the problem. Now we come to the problem number 5. So problem number 5, that is an oblique cone of diameter 50 millimeter and axis 70 millimeter long, having the axis inclined at 60 degree to the base, is resting on HP on its base with its axis parallel to VP. Develop the lateral surface of the cylinder. So here given, you can see here that this is an oblique cone whose diameter, this diameter is how much? That is 50 millimeter. Diameter is 50 millimeter. Means from here to here, this diameter is 50 millimeter. 50. You can see that is 50. Sorry, from here to here, this is 50 millimeter. And axis length means this is the axis. This is the axis. So axis length is how much? That is axis length is 70 millimeter. And the axis is inclined 60 degree to HP and an angle 60 degree to the base. Base means this is the base. So this is suppose this is HP, horizontal plane. So it is inclined at an angle 60 degree to HP. And so this is the front view of the cone. Front view. If we see it from the front, that is, this is the front view of the cone. And then this is the top view. This is apex. O is the apex. So here from the top we can see here, this is the apex here O, and we can see the circular portion also at the base, which is above the base. So this is the top view of this oblique cone. So if we see it from the top, then we can see this drawing. So this is the top view of the cone. So its base of the cone is a circular portion, and it is an apex. And these are the generators. OA dash and OG dash. These are the generators. Understand? Generators. So one generator, that is OA dash. Now from the top view you can see this is a circle, the base, that is a circle. So we divide this circle into 12 equal divisions. You can see here we divide this, as you know, earlier also in the previous drawings I have also tell you how you can divide this circle into 12 equal division. So this is 1 2 3 4 5 6 7 8 6 7 8 9 10 11 and 12. So we divide this circle equally into 12 equal division. Understand? So these are the 12 equal division. Now we project these divisions. Suppose this is OB, B division, OC division, and we draw a projection line up to the, from the top view up to the front view. We extend these projections up to the top view, and here you can see OB is represented here, OB and OL. If we join OL and OB, that is here OB. Similarly, another generator, that is OC. OC represent in the front view, that is OC. This is OD. This is OD. This is OE, and this is OF. So where OD is this line represent OD. This is OE, and this line is OF. You can see here in the drawing. Now these all generators, actually OA dash and OG dash, the generator, that is, we can see, if you see from the top, we can see the true length of only OG and OA. But this OB, OC, OD, OE, OF, OH at the back side, OI at the back side, OJ, OK and OL at the back side, that is also all are generated, that is not the true length whatever we see here. So we have to measure the true length of this generator by this process. I am seeing you this process. How you can see, draw the projection, join this OB and take the length OB from here, this generator, and we draw an arc through this and it joins it the horizontal line, this there. Then you extend this up to the base, means this HP reference line. Then if we join this O to the B, this is the true length of the generator. Means you can see here, this is, suppose this is top view, this is top view in front of you. If this is parallel to the top view, then you can see the original length, this pencil. And if this is inclined at an angle, then we can't see the original length. We can see the projection up from here to here, that is from this point to this point. So this is lesser than the original length. This is lesser than the original length because these generators are not parallel to VP. Understand? That's why we have to draw the true length. We have to calculate the true length. So if we extend this line up to the horizontal, this line, and extend this line up to the horizontal plane and join this one, then we can get only the true length of this OB, OC, OD, OE, OF. Similarly, OH, OI, OJ, OK, and OL. These are the true length of OAOB. Understand? And we can see only the true length of AB and OG because these AB and OG generators are parallel to VP only, vertical plane only. So understand? Now we have to develop the surface of this oblique cone. If we cut, suppose the lateral surface of this oblique cone, if we cut this cone, oblique cone, along the largest generator, this is the largest generator and this is the smallest generator. So if we cut the cone, oblique cone, along the longest generator, means that is OA dash is the longest generator, then we can see the development just like this. In this way, I am showing you this in this drawing. So take OA dash. This is the true length. So take O dash. Suppose here O dash. Similarly OA. Here place here OA. Now from O take the true length of OB. That this is not the true length of OB. The generator OB. The true length of generator OB is this one. We can calculate it by extend this portion up to this portion. So this is the true length of OB. Suppose this is OB. Now from this point we have to draw an arc taking the length OB just like this and take the OB, take the distance AB from this arc. Take the arc length AB. Suppose this is now AB. If we put there, then we can get the point B. So this is the point. This is the point B. Understand? This is the point B. Similarly, take the true length of what? Now OC. The true length of OC is this one. This one. True length of OC is this one. Understand? So from O, draw an arc here. Draw an arc, suppose this, and take the length BC from this division, from the top view BC. If we draw this This is BC, means we can get the point C also. C. Similarly, from O, take CD. If we want to take the point D after development, this is the point CD. Understand? This is the point CD. This is the point CD. Then you can get here. This is the point CD. If we want to measure the point D, then draw a line here and see D. D means this is the true length of OD. This is the true length of OD here. This is the point D. So we can get the point D here. This is the point D. Similarly, same thing. If we want to the point E, so take the true length OE. OE. This one is the OE. This one is the length of OE generated. Now here OE. This is the point OE. Draw an arc and take the from D to E distance. Take here from D to E. We can get here. So from D, take the radius and cut it. So we can get the point E also here. This is E point. Similarly, you have to point E. If we have to calculate the point F, F OF. What is the true length of OF? That is this one. This one is the distance true length of OF. So from OF we can get. You can draw an arc here and measure the distance EF from the top view. This is the EF from the top view. Then you can get the point F also. This is the point F. Then F, then G. Actually this is the true length because this is parallel to VP. That's why OG is the from the front view we can see the true length. So take true length from the front view. Understand? So the true length. Draw an arc here and take the distance FG from the top view here. So this is the point G. This is the, you can get the point G here. It is this one. By this way we can get the point G. Similarly, then again we have to take the true length of OG, then H. The next point is H. So OH, this is the true length of OH. This is the true length of OH. That is equals to OF1. So this is the true length of OH. This is the true length of OH. Draw an arc from O, just like this, and take the distance GH. Take the distance GH and cut it. And then this is the point H. Intersection. This is the point H. Similarly, OI. This is the true length of OI. That is equal to OE. So we have to draw here. Similarly, I. So take the length from the top view. The distance OI. This is the distance OI. So you can got the point here. I here. I. This is the point I here. You can see I. Then OJ. Take the general true length of OJ, that is equal to OD. Draw an arc and take the arc length of the arc, that is IJ. So this is the length, you can get the point IJ. This is the point J. Then you have to take the point OK. Next point we have to measure OK. So draw and from O to B, draw an arc here. OK. And here JK, take the length JK. Take the length JK. So take the from point, this is the point, junction point K. This is K. Then we have to take the length OL, that is OL. This one OL. So take the length OL from here and KL from the top view, that is KL, and from this point it is KL. So we got this point KL. So this is the point L. Then again from KL to again we have to take the point OA. So this is the true length of OA from here. This is the true length OA. So draw an arc here, OA, just like this OA and OA. This is just like this, and take the distance AL from the drawing, and join. This is the A. You then generated A, and now join this line. OA. Join this line OA and this point also with the help of a curve. Help of this curve. This point. So this is the development of an oblique cone. If we This is the development of an oblique cone. If we cut this cone along the longest generator. Understand? I think all of you can understand it. So thank you for today.